Good morning, class. This is Dr. Karsten, and today we are doing Lesson 28, and that is in Module 5, Grade 4 of EngageNY Math. In today's lesson, we're going to solve word problems with line plots. So this is something a little different. I'm kind of happy that we're getting to do something fun today. If you have a ruler, why don't you go and grab it, and then you can follow along. Also, I am going to be working in our homework set for the video. However, you are going to be working in the problem set when you're working at home. So something a little different. So just to be really clear, we are going to be working, or I'm going to be working in the homework set. Right now in the homework problems, you are going to be working in the problem set. But I do have both of these posted in our Google Classroom. So you will have everything available to you that you need, and you still have your workbooks at home too. All right, so let's jump right in. So for this problem, it tells us that a group of students measured the lengths of their shoes. The measurements are shown in the table. Make a line plot to display the data. So I don't know if you remember doing line plots before, but we are going to be making a line, and then we're going to be placing X's above it to represent the data points. So these are going to be our data points. This is our data. And let's go ahead and take a look at the table that was provided to us. So this is our data table. These are our labels for our two columns. So this is our independent variable, the students, and it's their names. So you can see we have a bunch of students here. And then here it says the length of shoe in inches. So this is our dependent variable. And for this one, you can see that we have a bunch of different lengths of shoes. I have 8.5, 7 3/4. So what they clearly did was this class measured the length of each student's shoe. And they made a nice table for us with all the information. Our job is going to be to represent that table on the line plot. Now, because the way the homework is set up, there's not really a lot of room underneath it. So I'm going to be using a separate piece of paper, and here I'll show you what I mean. They only gave us this much room, and I don't want to be limited. So I'm going to use a separate piece of paper to plot all of this data. Now, the first thing that you're going to have to do is you need to make a line. And if you have a ruler, that is awesome. So I have my little clear ruler here. It's going to be really reflective. I apologize for that. It helps if I turn it around. Now, I'm going to assume that many of you do not have a ruler, so I'm really only going to use my ruler to make my line for my line plot. I'm not going to be using it to do much else, because I really want to do what you're doing at home and make it as similar as possible. So I'm going to go ahead and draw that, but I am going to talk about how else you would use your ruler. So I'm just going to use this to make my nice straight line. There we go. So what I want to do is I also want to put my arrows on the end to show that my plot extends, because I'm not going to include on here from 0 to whatever number I need to go to. That would be a waste of a lot of space, and I'd really what happened here? And I really wouldn't be showing everything that I wouldn't be able to show everything that I needed to in detail. What I really want to do is figure out what should I make my end points. And that's going to be the first thing after you've drawn your line, is to figure out what are going to be my end points for this line plot. Why is this all worked? Hang on, gang. Let me see what's going on here. There we go. And so to do that, I want to find my range. I want to find my smallest number and my largest number on here. So let's go ahead and take a look and see. I have 8.5, so that's a pretty big number, 7 3/4. So let me see if I can find anything larger than 8.5 and smaller than 7 3/4. Well, here Marie is smaller than 7 3/4. I'm 7.5, 7 3/4, 8, 8.5, 7 3/4. 8 3/4. So this one is going to be my largest number that I need to plot. And then it looks like 7.5 is going to be the smallest number that I have to plot on here. So when I think then, what should my end points be on this graph? I'm thinking that I should go from 7 to 9. 7 is going to be less than this, and 9 is going to be greater than this. And so that would explain also why I have to have my arrows on here, because I'm not, again, showing the entire, range. This continues to the left and to the right. People could have a foot smaller than what those students did, and people could have feet larger than what those students had. So that's the first thing that I have to think about. Now, I'm not putting my endpoints on yet because I do want to show you something with the ruler. If you were using a ruler, you could actually be really exact, and you could use either your inches or your centimeters to make sure that all of your marks on here were equally spaced, were perfectly equally spaced. But again, I'm going to assume that you do not have a ruler at home right now. Maybe you do, and then you can do this. So because of that, I am going to do it without my ruler also. And I'm just going to determine, I'm going to put my endpoints at the ends. So I'm going to go ahead and I'm going to write that this is going to be 7, because again, we decided that our range was going to be from 7 to 9. This is going to be 9. And then right in the middle is where I'm going to put my 8. So there's 8. Now I have to think about where I want to put my marks on here. Where do I want to place them on here? And what kind of marks do I need? And what I'm seeing here is that it looks like everything is 1/4 of inches. Now you might be saying, wait, Dr. C, I see 1/2 inches here. Right, but 1/2 inches are equal to 2/4 inches. And we know that because we know how to make equivalent fractions. So when I look at this, I can say, well, it looks like I'm not going to have to go smaller than 1/4 inches, that I can stick with 1/4 inches and 1/2 inches to mark on here. So that's going to keep this pretty nice and easy. So that just means that I need to mark off where my 1/2 inches would be. And I'm going to mark off my 1/4 inches. Now, when you do a line plot, you're not going to be putting dots on here. Instead, you're going to be placing X's above the line. But before we do that, we need to do some labeling. We can't just leave it like this. We need to label what's going on our graph. So below the line is where I'm going to write what this line represents. And this line represents, oops, things are going to be moving around a lot today, the length of shoes in inches. So let me write that down here. Oh, see, I like to tilt my paper. I'm going to try and keep it straight. So we said the length of shoes in inches. Okay, so that, and it would have been nice if I'd had it over more, but the length of shoes in inches. So now we know that these represent inches, which means that a person could figure out that these are each 1/4 of inches. Here's my 1/2 inches. Okay, and you can see these are not actual inches. I made it so that it would be easier to represent. So what you can see is here that each one of my 1/4 inches is just under an inch long or apart. Okay, so now what we have to do is we need to title our graphs. We need to tell what it shows. And I'm telling you right now, if you don't do this before you start graphing, when you're done graphing, you're going to be like, yes, I'm done graphing, and you're going to forget to place the title, and you're going to forget to label what's going on. So always do these things beforehand. So what do we think would be a good title for this graph? Now, in the problem set, they give you more information about what's going on, and they tell you it's a class, and so you could say, the name of the teacher and the class, and what's happening in that one, and I think, what was it? It was Mr. Smith's class. And so you could actually talk, Mr. Smith's class. In this case, they just told us a group of students. So we could write that this graph is the length of shoes of a group of students, and here it says, lengths of their shoes. So I'm going to go ahead and do that and write length of shoes for a group of students. Shoes for a Sorry, I am being very messy with my title. And again, I didn't judge how long that was going to be very well. Okay, so lengths of shoes for a group of students, that's going to make me nuts. I think I need to go get my white out at some point and fix that. All right. Oh man, that's going to bother me, but I'm not starting over. Okay, we'll just make it disappear for now. Okay, so length of shoes in inches is the label for what this is representing here. We titled our line plot, which is a type of a graph. So now we have to start thinking about marking our data. Now again, we're going to be marking our data with an X. We are not going to be marking it on, we're not going to be marking it directly on this line plot. We're not going to be putting dots or points on here. Instead, we're going to put X's above. So we need to have a key to tell us what does each X represent. Well, in this case, each X is going to represent a student. So we need to write that. So I'm going to go ahead and put that right down here. X equals 1 student. All right. And, you know, I actually could have also done this before just to show that it's in inches, but that's just more information. It's really the length of shoes. Okay, so X equals 1 student. And now I think we're ready to get going. So we're going to start graphing or marking or plotting this data on our line plot. So I'm just going to move this a little up so I have it more comfortable. So one thing that I want to mention that's really, really super important is that every time you mark one of these off on our line plot, you put an X, you need to put a check next to this data so that you know that you placed it on there. Remember that some of these are going to, some of the data points are going to have, there's going to be more than one X. So we want to make sure that we don't miss anyone because that could really throw off your graph and later on any work that you do with that. So let's go ahead and let's start plotting. So we can see here Colin's length of his shoes was 8.5 inches. So what I want to do is I want to figure out where is 8.5 on here. And I can see that 8.5 is going to be here. We have 8, 8.25, 8.5, 8.75. And I'm going to go ahead and write down here 8.5. For a line plot, you do not need to mark off every single quarter inch on here and label them. I mean, we mark them, but we don't have to label them. We only have to label the ones that are really important. So I did put on my benchmarks. I'm just using the inch benchmarks for now. But I'm only going to put a label under these marks when I'm actually using them. And then I'm going to go ahead and I'm going to put an X above that to show that I have one data point there. So again, he was at 8.5, so I'm going to put an X and I'm going to check him off. And again, that's really important. So next I'm going to do Dickon, and he is 7.75. So let me go and find my 7.75. Let me mark it off. So here's 7.75. And I'm going to put an X above the line. And you're going to try and keep them neat and lined up with each other because that'll help you when you're taking a quick look at your data. So now let me check him off. And next we have Ben. Ben is at 7.5. So let me put that 7.5 in there. And I'm going to go ahead and put an X above it. So that's for Ben. And let me check him off. And Ben is going to be my smallest, remember? We had little stars there to show the range. Okay, now we have Martha. Martha is 7.75. Now, you can see 7.75 is already written for us, so we just have to put the X above it. And I'm going to check her off. So now we have Lilias, or Lilias. Lilias? I don't know. And her shoe, I think it's a she, I'm not sure, is going to be 8 inches. And 8 inches is right on here, so I can just put the X, and then I can check her off. Next, we're going to do Susan, and Susan is at 8.5. That's already on here, so I'm going to go ahead and just put an X above it. Next, we have Frances. Frances is 7.75. So that's going to be right here. Check it off. And then we have Mary. Mary has 8.75. So Mary has the longest foot. And I'm going to go ahead and write that on here. And I'm going to go ahead and place that X for us. And give her a check. All right, so our line plot is done. And it's looking good. We have our line, we have our range and our markings on here. We have our X's to represent our students. We've said that X equals 1 student. We've labeled it. We have that horrible title up top, which we're going to leave alone for now. And now we can start answering questions about this. But before we do that, let's take a really quick look and see how nice and easy it is to have this, how visible our data has become. I can really easily scan here and I can tell you what do I have the most of. That's 7.75. 3 students had 7.75. I can quickly see our range, which is from 7.5 to 8.75. And I can kind of really quickly see where people fall on here. So let's go ahead and let's jump into the questions that went along with this. So the first question that we have is, I need to move things around a little. Let me pull this out from underneath. So our first question is, who has a shoe length 1 inch longer than Dickens? So I could either look here and scan, but that's going to be a little like that. I'm going to have to look at each one of these really carefully. So I don't want to use my table. I definitely want to use my graph. So, but I do need to look at my table to figure out what was Dickens' length, which was 7.75. So if I look at 7.75 right here, and I want to go an inch longer, I go to 8.75 right here. And then we can go over here and see who had 8.75. And if I look for 8.75, right here, Mary had 8.75. So Mary, it would be our answer. Now, we should also show how we got that answer. We shouldn't just write her down. Let's show our work. And so what we could say is that Dickens was 7.75, and then we added 1 onto that. And that's how we ended up with 8.75. And we figured out that Mary was our answer. All right, so let's take a look at the next question. So for the next question, it asks us, who has a shoe length 1 inch shorter than Susan? So let's go find Susan. And for Susan, we have, hold on. Sorry, piece of dust on there. So for Susan, we have 8.5, and we want to go 1 inch shorter than 8.5. So let's do the math first this time. So I'm going to have 8.5, which is Susan. And shorter means I'm going to go smaller, right? And we're going to subtract. So we're going to subtract 1 inch. And that's going to be 7.5. So let's take a look and see who's at 7.5. And again, our line plot doesn't actually show us who is at 7.5, but there is 1 student there. I can see that on the line plot. And if I take a look here, Ben is at 7.5. So I'm going to go ahead and write Ben. And we could say Ben has a shoe length 1 inch shorter than Susan's, but for today it's okay for us just to write the names. Okay, so let's see what is next. Next page. How many quarter inches long is Martha's shoe length? So let's go ahead and let's take a look at Martha's shoe length. So Martha is 7.75, so I'm going to jot that down. So I have that to work with. And now we have to figure out how many 1/4 inches are there in 7 3/4. So think about how we've been doing our work. And what we need to do is we need to decompose these whole inches into 1/4 inches. How many 1/4 inches are there in one whole? That's the first thing we have to remember. Well, I know that one whole is equal to 4/4 or 4/4. Remember, quarters and fourths, same thing. And as long as my numerator matches my denominator, it's equal to one whole. Fourths shows us that one whole is divided up into 4 equal pieces. So I know that there are 4/4 in one whole. So then how could I figure out how many there are in 7? Well, I'm going to want to multiply 7 times 4/4. And remember how we do that? We can go ahead and just put that over 1, and then we just multiply straight across. Why can I put that over 1? Because it's 7 wholes, which means that it's not actually split up into anything. It's one whole. It has not been divided into pieces. There's just one piece for each whole. So 7 times 4 is 28. And then we have fourths, because 1 times 4 is fourths. And then what we know is that we also still have that 3/4 that we have to add on to that. And so we would end up with 31/4. So how many 1/4 inches long is Martha's shoe? I'm going to write Martha's shoe is 31 1/4 inches long. Okay, let's take a look at the next question. So D says, what is the difference in inches between Lila's and Martha's shoe lengths? Remember, when we're looking for difference, we're subtracting. So let's go figure out how long is Lila and how long is Lilia's or Lilias and Martha's shoe lengths. So hers, Lilias or Lilia's, is 8. And I'm just going to jot that because I like to keep my stuff nice and organized. And then let's go figure out what Martha is. Martha is 7 3/4. So one thing I can do is I could actually go back to my graph and take a look and see what is the difference in the length from 7 3/4 to 8. And you can see it's a 1/4 inch. Another option is that I could subtract. So we have a bunch of different ways that we could do this. But think about what's another way that we could do that. So one, we can take a look and see what is the distance, and I can see that it's a 1/4 inch. What else could I have done to figure out what is the distance, what is the difference there? I can't just go ahead and subtract, watch, 8 minus 7 3/4, and the reason is that I would be taking I'd be taking 3/4 away from nothing. I have no fraction written over here. But remember what we were doing before, and how what I could do is I'm going to work over here. Actually, I'm going to work on a separate piece of paper for this one. Oops, sorry for all the noise. So if I want to subtract 8 minus 7 3/4, let's remember how we did this. What I can do is I can decompose this 8. And I could put 7 over here and 1 over here. And then I'm going to go ahead and I can turn that 1 into 4/4. So now what I know is that another way of writing 8 is to call it 7 4/4. Now I could subtract 7 4/4 minus 7 3/4. And when I do that, I can see that my 7 is going to take away that 7. my 4/4 is going to subtract 3/4. I'm going to take 3/4 away from 4/4, and that just leaves me with that 1/4 that we saw in the graph. Now again, I think that for a lot of you, doing it horizontally might be a little confusing. I want to go back to what you're really comfortable with. So let's do it this way. Let's say that I have 8, and I want to subtract 7 and 3/4. So you can see that I have nothing here. I have no fractions here. I have no fourths here. So what I can do is, just like we've done in math when we're subtracting with whole numbers, is that we can go ahead and rename or regroup or go next door and borrow. But I'm going to take this 8 and I'm going to make it a 7, and I'm going to put one whole over here. But instead of writing one whole, I'm going to write it as 4/4, because I know that 1 is equal to 4/4, or 4/4 is equal to 1 whole. Now I can work. I can say 4/4 minus 3/4 is 1/4, because 4 of these size pieces minus 3 of these size pieces leaves me 1 of those size pieces. And I can say 7 minus 7 is 0. So what do I have? I have 1/4 inch. And again, I think that's going to be a lot easier for a lot of you to think about, because that's what you're comfortable with from years of adding and subtracting. So let me go ahead and write this down. And I'm going to leave it the way it is because I did all my work over there. I'm going to write down, though, that that's equal to 1/4 inch. And don't forget to label. Okay, next one. Compare the shoe length of Ben and Francis using greater than, less than, or equal to. So again, I want to have my information organized. So I'm going to have Ben and Francis. And let's take a look and see. For Ben, we have 7.5. And for Francis, we have 7 3/4. And for this one, I'm definitely just going to jump on my graph because we already put everything on here. So we have 7.5, we have 7 3/4. And so you can see that 7 3/4 is definitely going to be larger. Now, let me go ahead and do this. So Francis was 7 3/4, so Francis is larger. So Francis's shoe is larger. Now, here's the thing. What if I didn't have that graph? Would you have known what to do there? Well, I hope that you would have said to me that, well, since my 7s are the same, my whole numbers are the same in these mixed numbers, I can just look at the 1/2 and the 3/4 and decide which one's larger. And at this point, I think you're probably pretty comfortable in knowing that 3/4 is larger than 1/2. One thing you could have said to me as well, I know that 1/2 of 4 is 2, so 2/4 would be equal to 1/2, so 3/4 is greater than 1/2, right? Or you could have turned this 1/2 into fourths by multiplying the numerator and denominator by 2, and you would have ended up with 2/4. And then you could have said 2/4 is less than 3/4. So those are some of the skills that we've been working on the last few days, and I hope that you would remember to use those. Let's take a look at the next one. How many students had shoes that measured less than 8 inches? Well, that's definitely going to come straight from our graph. That's going to be the easiest way to work with this. So we need students that are going to be less than 8 inches. So we want to go to that side of the 8-inch mark. Do not include the 8. It wasn't less than or equal to. It was strictly less than. So only shoes that are smaller than 8. So let's go ahead and count. 1, 2, 3, 4. So that's nice and easy. Oops, how did I end up on the wrong page? There we go. So 4 students had shoes. And I'm not going to write, I'm just going to write less than 8 inches. So you're not bored watching me write. Okay. How many students measured the length of their shoes? So for this one, they're asking us what was the total number of students that participated in this. And we could use either our table or our line plot. So let's go ahead and take a look at our line plot. We have 1, 2, 3, 4, 5, 6, 7, 8. And 8 students participated. So 8 students measured. I'm trying to use exactly what they have here, the length of their shoes. Hey guys, is it a cursive day? Mr. Jones' shoe length was 25½ inches. Use greater than, less than, or equal to compare the length of Mr. Jones' shoe to the length of the longest student's shoe length. Who had the longer shoe? So first we have to go and figure out which student had the longest shoe. So let me go ahead and grab our table. And we had already put stars here. I could have first looked at my graph to figure out who I'm looking for, which was 8 3/4. And then I could have skimmed down this to see who had 8 3/4. But we'd already marked it off earlier. And we know that it's Mary. Mary has 8 3/4 inch long shoes. So I'm going to jot that. I like to be nice and organized. Let's move this up. So Mary equals 8 3/4 inch long shoes. So now we have to be able to compare Mr. Jones and his 25½ inches to Mary's. So what would be the best way for us to do that? How are we going to compare Mr. Jones's shoes with Mary's shoes? Well, I have 25½. What I want to do is I want to turn that into a mixed number. And I'm going to be pulling out ½ inches out of this. This is going to be a whole lot of ½ inches. Guys, are we ready to just use skip counting? Because we've been doing a lot of this, right? Could we just use skip counting and see? Let me write out our multiples of 2. So we have 2, 4, 6, 8, 10, oh my goodness, 12, 14, 16, 18, 20, 22, 24, 26 is too big, walk it back one, so 24. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Guys, do I have to actually draw this out? He has really long shoes, doesn't he? That's 12 inches plus a little bit more. So if you were doing this the long way, you are going to have to go ahead, and this is going to be really long. So I'm going to start way over here. I'm going to pull out each inch, and each inch is made up of 2 halves. And I know that because I know that 2 halves is equal to an inch. My denominator is 2, so that's what I'm pulling out of here. Oh my. So that would be 2, 4. Notice how I'm skip counting. 6. 8. 10. 12. 14. 16. 18, so I've done 18 halves so far, 20 halves, 22 halves, 24 halves, and if I did another 2 halves, I'd be at 26, so it'd be too big, so instead I just have 1/2 more. Oh my goodness, that's a lot of halves. So each one of these halves represents a whole. So I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 holes plus another half. So what is this? It's 12 holes plus that half. Wow. So Mr. Jones has a shoe that's 12½ inches long. So that's longer than my ruler, guys. That's pretty long. Those are some big shoes. So clearly, Mr. Jones has a longer shoe length than Mary. But remember, I'm not going to write it. So I'm going to write Mary. I have 8 3/4. And I'm going to have Mr. Jones, but I'm not going to write 12½. I'm not going to write this number. This is just what we use to understand it. I'm going to write the original fraction, greater than 1. So he has a shoe length of 25½ inches or 12½ inches, and his are clearly larger than our friend Mary's. And then I could write that Mr. Jones's was longer, but we don't have to. It just said use this to compare them. So we're good. Wow, that was a lot. Okay, let's look at, number 3. I'm not going to do number 3 with you guys. You guys are welcome to do that on your own. When you're doing the problem set, you just get to make up your own question. I could talk about the difference between the longest and the shortest shoes or anything else that I can think of that hasn't been asked yet. All right, class, so as a quick review, we did our line plot to represent the data, and look how beautiful that title has turned out. Yeah, I went back. Okay, so remember, when you are doing your line plot, just to review, the first thing you have to do is you are going to try and make the straightest line you can. If you are using a ruler, you can then actually make your marks on here perfectly even. Otherwise, do your best to try and make them even. How did I know what my end marks were going to be? I looked at my table. So I made my line, I made my end marks, and I figured out what was my shortest and my longest point that I would be plotting. And then I knew that that gave me my range. But you want to go a little bit longer and shorter. So I went to the nearest whole number. So since I had 7½ I went to 7. I went a little smaller for my smallest. And I had 8¾ so I went up to 9 for my endpoints. After you have placed your endpoints and you have your range from smallest to largest, you want to label what's going on this line. What does this line represent? So that's where I placed length of shoes. And then what I did was I went ahead and I wrote a title, because if you don't write your title before, you're going to forget to write it after. So lengths of shoes for a group of students. And then I went ahead and I marked the data using X's. And I also had to show what does that X represent. So we gave a little key here. X is equal to 1 student. So again, draw your line, figure out what your range is going to be, smallest to largest. Try to mark it as evenly as you can on here. Label what your line means. Place a title. Give a key. And then put your X's above the line to show what your points are. You want to plot all your points. And as you're going, for any of these marks that I'm using where I'm plotting points, I definitely want to label those marks too. All right, and then you have your data done and you are good, and then you can answer any questions. So what you are going to do is you are actually going to do this in the problem set. In the problem set, you are going to do questions 1 and 2. All right, I will see you in our Google Classroom.